SoCal's lunchtime webinars. We're really happy that you're here today. Thank you so much for participating in our webinar series. It's our pleasure to have DSA with us today. They are one of our very generous sponsors. They are at the platinum sponsor level, which is the highest level of sponsorship. We greatly appreciate their generosity, and we realize that it's very hard for them to get into offices these days because we are not there. So we are bringing them to you today, and they have wonderful information to share with you. So I'm going to introduce you to Sarah Lanners, who is one of our chairs for our Emerging Professionals Committee. This webinar is brought to you by the Emerging Professionals. And so, Sarah, please take it away.
Okay, thank you everybody for joining us, and especially thank you to Mary Kay and Niki. I just want to do a brief introduction on the both of them. Mary Kay is an outside sales team member for David Silverman and Associates, DSA. She earned her Bachelor of Science degree in Interior Design at Cal State University, San Jose, before working in many areas of the industry, including design, real estate, and architectural and design product education and sales. She is a lead AP, ID+C. Mary Kay has extensive experience, more than 20 years working with architects, landscape architects, designers, and end users, bringing her knowledge, creativity, and positive perspective to each project. She is a team player who successfully collaborates with clients and manufacturing partners to identify appropriate products and materials to meet design concepts. She strives to find outstanding solutions for projects, resulting in positive customer experiences. And then Niki began her career in commercial electrical administration and product management. Although her education and interests are focused in the areas of graphic design, fine art, interior design, and architecture. The design build projects requiring extensive coordination with architects, lighting designers, and engineers stimulated her passion for lighting and site furnishings. She holds the position of secretary on the Orange County selection of the Illuminating Engineering Society. Niki is now a sales representative with David Silverman and Associates, an independent agent specializing in representing architectural lighting and site amenities from the finest manufacturers in the world. She is pleased to support the Greater Los Angeles area market in transforming places and spaces for an ideal human experience. I also wanted to remind everyone that please put any of your questions into the Q&A, and we will be fielding those at the very end of the presentation. Okay, thank you.
All right, thank you so much, Sarah, for that introduction. I'm going to dive right. For those of
there you are.
Yeah,
You went on mute for a moment there. Okay, go.
For those of you who maybe aren't familiar with DSA, we represent some of the most celebrated lighting and site amenity manufacturers in the industry, and one of which is Landscape Forums, who created most of the content we're going to see in this presentation. So this presentation is going to focus on what you need to know about lighting as a landscape architect, but it'll also provide some fundamental themes that would be useful to any designer dealing with lighting. So our hope is that this presentation will increase your comfort level when you're involved in selecting lighting that complements your designs. So we'll primarily address pedestrian and pathway applications and the overall visual experience, meaning how we see and interact with the characteristics of lighting, such as contrast, glare, and color rendering. The elements that will impact visibility in the nighttime environment. We will also talk a little about LED technology and terminology, just to provide a better understanding of the tools available to help evaluate LED lighting on your projects. So when it comes to evaluating how well a space is illuminated, the current standards focus on illuminance, which is the amount of light cast onto a surface, and it can also be referred to as foot candles. So this is what we're seeing here in the photometric layout. And safety in foot candles has become this default mindset for illuminance. And such thinking actually causes a lot of frustration for lighting designers and can be a major challenge when designing spaces for pedestrians. So we just covered illuminance, and luminance at the bottom of this diagram is about our perception. It can be the lighting coming directly from a source or reflected light. Our experience of a quantity of light will be different on black asphalt versus a concrete paver. And that's because of each material's ability to reflect light. So a good comparison would be 110-degree temperatures in the desert versus 110-degree temperatures in the tropics. Although the air temperature may be the same, the perception, or our perception and experience, will be very different due to other factors. So it's important to understand that illuminance and luminance will impact visibility and reassurance, which can also be called sense of safety. So some of the elements considered in lighting design are safety, and that is whether or not the light levels are sufficient for a particular activity and application, or even whether they support the perception of being safe in a space. And then there's also standards that have to be met. So a design must meet minimum criteria such as that are set forth by organizations such as the Illuminating Engineering Society, and also California Title 24. There's also the environmental impact to consider, which ties into standards and or addresses things like light trespass onto adjacent properties. Whether a light fixture or installation can be easily maintained or serviced will also come into play. And then of course we have economics, which can translate to cost, value, or in cases of renovation, return on investment. So let's dig into the visual experience, which will cover glare, color rendering, and uniformity. And we'll talk about how each of these impact visibility and perception of safety. So we're going to talk about how we can tweak and adjust those variables within a Luminaire to get the desired outcome. The first thing to keep in mind is that we don't want lighting to give us the same experience that we have during the day. A more natural approach would be to use moonlight as inspiration. Outdoor lighting should mimic elements present at night in a natural way and adhere to the functions and mandates of nature. So this points back to the importance of considering the environmental impact of lighting outdoor spaces. And glare, reducing glare always improves visibility and a sense of safety. The adaptation of our eyes when exposed to glare reduces our ability to perceive colors and contrast. So if you look at the photo on the right-hand side, where the glare is minimized, you start to see the details, the color of the pavement, and these posts. Things actually come into view, even the horizon back there. But when you look at the picture on the left, from the Luminaire down, you could almost assume that it's a black and white photo, that there's no color involved at all. So that just gives you an idea of how that glare can impact visibility. And it's important to note that the degree of sensation of glare is dependent on factors like the size, position, and luminance of a source. The number of sources and the luminance that our eyes have adapted to in a space will also impact the sensation of glare we experience. And a good illustration of that would be when we're driving down a road and the roadway lighting is comfortable and our headlights are comfortable and we are safely driving down the road and we have an oncoming car that has their high beams on, and how that will impact our ability to see beyond that point. But if those high beams were shining directly at us during the day, on a sunny day, we would not have that same discomfort. So this is a photo that's provided by the International Dark Sky Association, and it's another great example of how glare affects visibility and in turn safety. This is a small space, but if we were to actually analyze what's happening in the space as far as the lighting goes, we might say the foreground is well illuminated, and this background near the gate could use maybe an additional fixture. Maybe that would be a thought for a solution, is adding another fixture to get more light in the background. But what could actually happen is we could make the situation worse if we use that same fixture that has all of that glare. We might get some more light in this area, but we would definitely have more glare. And it further illustrates how the variables need to be considered holistically for the best possible solution. Because in this image, we can see that this hand blocking the glare of the light fixture is essentially doing the job of a well-designed luminaire. Suddenly we can see that it's not an intruder entering our property, but maybe it's just our neighbor coming by to tell us that our light is shining through their bedroom window, which is something that Mary Kay is going to talk about later in the presentation. And the details of the space also start coming through. We can actually see the details of the gate and the pavement, and there's a better sense of safety. So a well-designed luminaire will direct light where it's needed. And moving into color rendering, which is essentially how well a light source can render the color of an object. So CRI, or the color rendering index, is a scale from 0 to 100, 100 being best. And although you may have heard TM30 is replacing CRI as a more accurate metric for color rendering, but that would be a separate presentation best given by an expert. And so a higher CRI will increase the ability to distinguish one color from another, or variances of the same color, which also impacts contrast. In this image here, we have adjacent spaces. We have one with a white light source that encompasses more of the visible light spectrum. And we have the area with high pressure sodium light sources that cast everything in this orange hue. In this parking lot, you can see very small in the corner here, we have a 22 CRI rating and 3 foot candle average. So again, those foot candles, that's how much light is actually being thrown onto the surface, and that's at 3 foot candles. If we look at this image, we have a CRI, a better color rendering index of 82, and we have a 0.8 foot candle average. So less than a third of the foot candles are actually being put on the surface with these fixtures. And although we have less light being put on the surface, we have a huge improvement to visibility and the perception that the space is brighter and safer. So this illustrates why foot candles alone are not a reliable measure for properly lighting a space. The last component of the visual experience is uniformity, which goes hand in hand with contrast. And uniformity compares the lightest to darkest points within a space. We have more uniformity in the even illumination as shown on the roadway in the background, and more contrast or less uniformity in the striation shown on the pathway in the foreground. And this is just another illustration of how the use of lighting is specific to each application, how it really needs to address the activities taking place within a space. And if we applied the contrast of the striation to the roadway, it could have a negative impact on drivers moving at a certain speed. And the uniformity of the roadway lighting applied to the pathway could diminish the intended vibe. You no longer feel like you're walking along a path at night, which we talked about, not creating daytime experiences at night in a previous slide. So to summarize these 3 components, we have a nice visual illustration. And we have this project example of 16th Street in Denver, Colorado. And this is a pedestrian avenue with bus lanes. If we pay attention to the 3 components we've been talking about, we start with glare. Glare is actually pretty well managed based on this image. And The CRI is very low. We see everything is washed in orange from the high pressure sodium light source. And if we look at some of the details, we start to lose a lot of details as we move into the background. We can no longer see exactly where the tree branches and even the supports for the light fixtures end and begin. But if we evaluate the same space after the fixtures have been retrofitted with a white LED source that encompasses more of the visible light spectrum, we can see the color of the planters. We can see the surrounding trees and the structures, and the perception of safety is improved. And it appears to be brighter, but we still have minimal glare. And the improvements are not only important for the visual experience, but also being able to see the design elements of the custom fixture. A lot of work put into designing this fixture, and being able to step up closely and take a look at those details is also important. So you don't want to have a lot of glare coming out of a light fixture, especially when it's meant to be viewed as kind of more of an artistic piece of the experience. So let's get into the technical components. The LED, or light emitting diode, it's technology that has followed almost about 100 years of no change in lighting technology. It started out as being used in higher power outdoor applications, but now of course is integrated even into the smaller scale low voltage fixtures. And LEDs efficiently use energy. They have a longer life than traditional sources, and they're better for the environment and are easier to manipulate with controls. So efficacy is a term that is interchangeably used with efficiency. It's typically measured in lumens per watt, and it's the amount of light produced for each watt of electricity consumed. So if we look at this chart from the years 2002 to 2015, at the bottom from left to right, and on the left we have lumens per watt, so we go higher as we get to the top of the left side. We can see that if we follow this blue line that starts about where the efficiency of an incandescent fixture is, if we follow the blue line up, we can see that the LED has actually improved in efficacy or efficiency, and it continues to actually improve, where all of these other traditional light sources have remained the same. Now, to look at an LED and what's involved in that, we have these components, and typically it's an LED chip is composed of a semiconducting material, and it's on a base of silicon and coated with yellow phosphor to produce the white light from the LED's blue light. And all of this is enclosed in what's referred to as a package, an acrylic or silicon lens. So lumen maintenance is another important thing to pay attention to. It is the life cycle of the LED. The light output of an LED decreases over time. So on a spec sheet, there's often an L70 rating of, for example, 80,000 hours. And this is referring to the number of functioning hours achieved by a light source to the point that it depreciates to 70% of its original light output. So to illustrate that, we have this graph, and it shows the thousands of hours at the bottom and the percentage of light output on the left. And the blue line, again, represents the LED lifespan. So there's this gradual depreciation from 100% output down to 70% output, and this gives you the thousands of hours in the bottom, which is 60,000 in this illustration. That is the lifespan of this LED. So being aware of this gives the end user an opportunity to plan for future upgrades, and in some cases replacement of Luminaire components. And these ratings will vary among fixtures. It's heavily dependent on how well a Luminaire is designed. Which leads into our next topic, the components of a Luminaire and how they impact performance and improve the visual experience. So we're going to take a look inside this pole mount luminaire. And this is exploded view. We first have the cartridge and heatsink. So the heatsink is often part of the cartridge, which will house the LEDs that we looked at earlier. And we'll talk more about the heatsinks and their purpose in a couple of slides. The optics, which are sometimes referred to as secondary optics, they aid in distributing the light from the LEDs and aiming it in different directions. So we'll also, Mary Kay is going to touch on how the different distribution types as a result of those optics. And then we also have a diffuser lens. And this will soften or diffuse the light exiting the luminaire, and also aids in reducing glare. And then we have the driver, and the driver delivers the appropriate amount of power to the luminaire. And then a lot of fixtures will have a surge suppression or surge protector. And these devices are an added measure of protection from spikes in power. So the idea is that if there were a surge in power, the relatively inexpensive surge protector would receive the damage in lieu of the driver or the luminaire. And lastly, we have the cover plate, and all these components work together to create a luminaire. So thermal management. One of the things that can greatly reduce the life and functionality of an LED is the heat it produces. So thermal management plays a critical role in preventing shifts in color temperature and premature failure. In the infrared image here, we see that the fixture is warmer where the LED cartridge is at the top, although it's only 65.7 degrees Fahrenheit, so that's relatively cool. And then as we go down the body of the fixture into the pole, those temperatures are reduced. So the heat is dissipated from the source down into the aluminum components and into the ambient air. And heat sinks are designed similar to this fin-like image we see here at the bottom. And they're really grooves and spaces that encourage airflow and aid with keeping the LEDs cool. Adaptive lighting elements or controls, such as motion sensors and photocells, which allow lighting to remain off or dimmed when an area is not in use or when daylight is present. They have added benefits and are reducing maintenance and also reducing the amount of energy used. At the top of this fixture, we have a twist lock receptacle that can accommodate devices such as photocells, and beneath we have a motion sensor. But there are other components that can come into adaptive lighting elements. They go into these bollards, for example, by Bega, that incorporate car charging units or stations. And they can either be capped with a blank plate, or they can actually have a luminaire on top. So they'll have a dual purpose. And this light column by Bega has a couple of different lighting elements, but also incorporates a Wi-Fi module. And this is just a quick little diagram provided by Structura that just illustrates the smart city and the multiple layers that are possible with components that can be added, adaptive lighting elements that can be part of a whole system in a city. So maintenance and service. The longer the lifespan of an LED, or the longer lifespan of an LED, actually reduces the amount of maintenance required, but there is a level of maintenance that each manufacturer will instruct as being essential to the effectiveness of the system. And selecting luminaires that ship pre-wired and fully assembled, if they have a quick method of disconnecting and replaceable LED cartridges, drivers, and things like that, that makes things so much easier. And honestly, this type of criteria will be met by the reputable manufacturers in our industry. And there are features that go above and beyond. For example, Bega has a a 20-year promise, and they guarantee that they will continue to supply compatible LED modules for 20 years following the purchase of a Luminaire. So this means at the end of, or an end user doesn't have to purchase an entire Luminaire when the life of an LED module expires. If it's within that 20-year period, they can get an LED module replacement and keep that fixture. So that concludes the first portion of the presentation. I'm going to turn it over to Mary Kay to finish.
Nice. Hi, everybody. So second part of the presentation. I'm going to talk a little bit more about design and how you use lighting in your designs. So as you might suspect, outdoor lighting design is very application specific. No two projects are alike, and therefore the lighting design will vary as well. You really need to understand where the light is going to go in order to effectively evaluate if a fixture is right for your project. Whoops, sorry. There we go. This slide shows a variety of common outdoor luminaire types used to light pedestrian and pathway areas, as well as perhaps some other outdoor spaces. The pole mount is pretty self-explanatory. Niki went over that. Catenary mounted fixtures are hung from a wire and are supported at the ends, either by a building, a structure of some sort, or poles. These are more common in Europe than they are here, but this style is gaining popularity as it allows you to get rid of poles in some instances. Path lights or bollards are typically below human eye height and tend to have a lower light level. Pendant mounted fixtures may be used at structures or buildings. They're sort of cousins to the catenary fixtures. Wall mounted fixtures can be used to continue a lighting theme along a building. And in-grade lighting can be used to uplight open areas, highlight walls, trees, or other elements. And we'll see some examples of these later on. With the advent of LED fixtures, it became much more feasible to direct the light that is coming out of a luminaire in the way that you want it to. Distribution types can be a wonderful tool in the lighting designer's toolbox if you know how to use them. As illustrated here, types 1 through 4 are asymmetric lighting patterns. The little black dot represents the location of the LED cartridge. Type 1 is the most linear, and as we move through types 2, 3, and 4, the pattern of the light produced gets more rounded and is thrown further in front of the fixture. Type 5 is symmetrical, and typically the light is thrown in a 360-degree pattern. These distribution patterns are an industry standard. The bug rating system, I don't know how many of you have heard about this, but the bug rating system gives you a description of where the light is going to go after it leaves the lens. Backlight is the percentage, whoops, sorry, my thing isn't working. Backlight is the percentage of light that is distributed behind the fixture. Uplight is the percentage of light that is distributed between 90 and 180 degrees vertically or above the fixture head. And glare, as Niki talked about earlier, in this instance, it describes the amount of light that is distributed between 60 and 90 degrees vertical. There's something to remember about bug ratings, and that is that there is no bad bug rating, just inappropriate applications. This is a typical Vega specification sheet. The bug rating is shown in the middle right of this page. The larger the number, the more light trespass there is. So a fixture with an uplight rating of 2 has more light going up above the top of the fixture than a fixture with an uplight rating of 0. A wealth of other information can typically be found on the specification sheets for most manufacturers. This is a real photo of the NASA Black Marble project. Light pollution is caused by overlighting, lighting that is bouncing off of objects, and or uncontrolled lighting. Not only is light pollution a waste of energy and money, but it is a serious threat to our environment. You can find more information about the International Dark Sky Association, or IDA, including a list of fixtures that meet their criteria on their website, which is www.darksky.org. One of the things that the International Dark Sky Association has come up with is a list of lighting zones shown here. LZ0 is the most restrictive and is meant for wilderness type areas, while LZ4 is the most lenient and generally is meant for urban areas. This slide gives a quick reference as to how the bug rating correlates with the dark sky lighting zones on the previous slide. If you are working on a project in an area that you suspect could be in a light sensitive area, you will need to do your research to make certain your lighting design and fixtures specified meet the criteria for that area. Light trespass is a problem that occurs mostly in urban areas. This photo shows a perfect example of this concept, where a street light is shining into someone's bedroom window. There are several solutions for this type of problem, including shielding the light, turning the light off after curfew, or making certain that the fixture utilized directs the light down and in front of the fixture. So for instance, a B0, U0, and low G type fixture. The luminaire types on this slide show some of the specialty lights you may want to use on your projects. String lights, aka Tivoli lights, fairy lights, Christmas lights, etc., come in different sizes and lumen outputs. Step lights are typically mounted at a wall and come in various shapes and sizes. Spotlights also come in a wide variety of sizes and wattages. Small spotlights can uplight trees, signage, artwork, or other features, while the largest spotlights can illuminate large building facades. Underwater lights can highlight pools or fountains. Note that there are special safety ratings for swimming pools meant for humans. The neon alternative type fixtures can highlight buildings and structures or create signage and artwork. Illuminated handrails are a relatively new category of fixtures that are gaining traction in the marketplace because they can illuminate stairs or steps much more evenly than traditional step lights. LEDs allow you to create all sorts of special lighting effects easily. But in order to tell the LEDs what you want them to do, you need to use a control system. The two most popular control systems are the Digital Addressable Lighting Interface, also known as DALI, or the Digital Multiplex, known as DMX. Basically, they both work by assigning different characteristics of the LEDs an address on the control system. Each luminaire could have multiple characteristics such as color, dimming, on, off, etc. The main difference between the two systems is that DALI provides a two-way communication between the luminaires and the controller, while DMX is a one-way system between the controller and the lights. Both can be used to control other electronic devices in addition to lighting. The color of lighting used is also a powerful tool that can impact your design. The correlated color temperature defines the range of white light and is measured in degrees Kelvin, or abbreviated K. The lower the number, the warmer or more yellow the light. Ecologically speaking, the most appropriate color temperature of outdoor lighting should be similar to moonlight, or somewhere between 3000 and 4000 K. This slide shows a photo that I received from a client in Los Angeles. They had specified the lighting mounted on the walls and the spotlights above it from two different manufacturers, both to be 3000 K. But when they were installed, to their horror, the lights were two radically different colors. Be aware that each manufacturer of LEDs may define their color temperature slightly differently, and the colors may fall within a range as opposed to one set value. If you have a similar situation and must use fixtures from two different manufacturers in close proximity to one another, you might want to request a sample from each manufacturer and look at them next to one another. Another reason why it is important to specify outdoor lighting to be between 3000 and 4000 K is that bluer light mimics daylight, which can disrupt the circadian rhythm of all human beings. I'm sure you've heard recently that you should not look at your phone or your computer screen late at night because it can disrupt your sleep. It is the same principle at work here. Some scientists believe that other living creatures, including plants, might also be impacted by exposure to bluer lights at night. There are some areas of the country that already mandate the use of amber-colored lighting near coastal areas where sea turtle migrations occur. Turtles don't see amber lights and therefore they don't impact their migration or breeding patterns. Several of the manufacturers that we represent offer amber LEDs as a standard. Whether you are trying to meet the criteria of one of the environmental rating systems or not, hopefully you are all concerned about the natural environment and how the products that you specify could be impacting it. LEDs are much safer than fluorescent sources because there are no toxic chemicals used. Do your best to specify fixtures that are made from a recyclable material such as aluminum or steel. Also consider packaging, manufacturing locations, shipping methods, manufacturing processes, and energy consumption. Also closely aligned with being environmentally minded is being mindful of quality. Light fixtures that will fail within a short period of time are not a bargain financially, nor are they an environmentally sound choice. If your contractor is trying to substitute an alternate fixture to one that you know and believe is a high quality choice, do not hesitate to order a sample of both fixtures and evaluate them side by side, possibly even in front of your client. Generally, the full cost savings are not passed along to the client, but end up in the contractor's pocket, and your client ends up with an inferior product. This example, courtesy of Vega, shows a project at UCLA. This original fixture was specified for phase 1 of a project. Note the color of the lens in the close-up and also the base of the pole. A couple of years later, when phase 2 was built, the contractor substituted a less expensive but similar looking fixture. The slide on the right is the substitution fixture. Look at the lenses of the substitution. They turned yellow and clouded within a short period of time. The arms that support the lights are much more flimsy than the original. In fact, you can even see bare wire on the photo on the left-hand side. Also notice that the base is already showing signs of wear and tear, even though it is newer than phase 1 fixture. Lastly, be certain that any fixtures that you specify have one of the safety and fire rating certifications. There should be a physical label on each luminaire. Underwriters Laboratory, or UL, is the most common and well-known testing entity, but Canadian Standards Association, or CSA, and Electrical Testing Lab, or ETL, are also quality labs and are becoming much more commonplace. The CSA label needs to have a US on it in order to be valid certification in this country. Okay, so finally, we're moving on to a more entertaining portion of the presentation, or project examples. Most of these examples are projects that utilize products from manufacturers that we represent. However, some of the images I pulled from the internet to illustrate a point or a concept. This first slide is a photo of the Hillcrest Park in Fullerton, designed by Studio NLA. It features Ashbury lights from Landscape Forms. Good lighting can create an emotional response. If you see a photo here that evokes an emotion in you, try to figure out what element or elements are causing those feelings. When you are developing your lighting concept for your projects, there are many factors to take into consideration, some of which are noted here. Most of these elements are the same as any type of design project. The pole lights in this slide are from Bega. I have organized these photos into a few categories of projects that you will probably encounter in your work. The first section is lighting for pathway or walkway. These fixtures are also from Bega in this slide. Notice the shadows or patterns on the path that these lights create. Is this something that you like and find appealing or not? This is a project at Cal Poly Pomona. Notice that all the lighting is pole top lighting with some ambient light that is coming from the adjacent buildings. As a contrast to the previous slide, notice how even and shadow-free the illumination on the ground is here. These are also Bega fixtures. Here we have a wide pedestrian walkway illuminated by landscape forms, all cut fixtures. These are a much more transitional style than the Bega fixtures from the previous few slides. Do these evoke a different emotion to the space for you? This is an example of a pole top light where the light is spilling in all different directions, including up. They create a nice rhythm or pattern down the pathway, but would not be a good choice in a dark sky environment. The bug rating for this Bega fixture is B2U5G3. By contrast, these are 3 photos of the Port of Long Beach, Wilmington waterfront. These semi-custom Hess ferro fixtures and poles are very attention-getting. The primary optics project light upward into the faceted secondary reflector consisting of computer-designed injection molded plastic modules, which are vacuum metallicized for specularity. Facets capture then redirect the light beams, producing a uniform square pattern on the ground. With cutoff of less than 60 degrees, the light quality is both effective and unobtrusive. You might ask yourself if you like the fact that these fixtures are attention-getting, or do you find it distracting? This is a street illuminated catenary-mounted fixtures. This is a street in Heidelberg, Germany, and they used Hess fixtures here. This slide shows a large-scale plaza adjacent to a building that is illuminated with rows of pendant-mounted RNA fixtures from Santa and Cole and Landscape Forms. This next slide is an outdoor dining area which was lit with custom Structura Aura fixtures that have been catenary mounted from the adjacent building walls. Do you consider this a successful application? And these are round versions of the same Structura Aura fixtures, here used to provide lighting at a playground area. These catenary fixtures were suspended from some of the poles at the perimeter of the space. As mentioned previously, using building-mounted wall sconces is also a common way to light a pathway adjacent to a building. These are Bega fixtures at a fire station in Germany. Oops. Oh, there we go. Sorry. And these RNA fixtures are lighting the entrances to some restrooms. This is an alley using Hess wall-mounted fixtures. And this is a decorative wall sconce from Hess that is illuminating a building arcade. Outdoor conference rooms and classroom spaces are becoming more commonplace, especially in California. You can use a decorative pendant light to light a table, or you can use a pendant mounted light like this over a picnic area. Rather than using some sort of overhead lighting, some pathways are lit with fixtures placed at a lower level, typically below our sight lines. The following slides show a few examples of what that lighting looks like. This is Marina Park in Newport Beach, California. Notice how these lights create areas of light and shadow on this path, like Niki talked about earlier when we talked about contrast. These small scale path lights from HK Lighting are placed in a Japanese style garden. Notice how the shape evokes that architectural style. These are a Bega path light. Notice how the light is thrown in a very distinctive front and back distribution pattern, and also the strong pattern of light and shadow that they create on the ground. When you see these two Bega path light fixtures side by side, you can see the difference in the light distribution. The fixture on the left is throwing the light more forward. There is almost no light on the grass behind the fixture, whereas the one on the right is a type 5 distribution, and the light is being thrown not only on the pathway, but on the plants to the rear of the fixture. So if you were selecting lighting for a similar application, which type of lighting would you want to see? This is a very dramatic photo from Bega showing how a very low mounted fixture is doing an excellent job of illuminating the paths, but hardly anything else in the surrounding areas. This type of lighting concept would probably not be the best for a public application, as the faces of people approaching each other from opposite directions would not be visible. Therefore creating a sense of insecurity and lack of safety. Here, a series of Bega step lights not only illuminate a series of wide steps, but also create a wonderful pattern in this landscape. Being landscape architects, I'm certain there are times that you want to highlight parts of your landscape creations at night. So this next section of lights will show some examples of how that can be accomplished. This is a photo that I pulled off the internet. I just love how the string lights were used to create a dramatic feature of this mature tree, and at the same time illuminate the wedding party in the area below the tree. Here, a series of low lights and up lights were used to highlight this creek-like water feature and the surrounding landscape. Here in Southern California, we get asked all the time how to effectively light tall palm trees. These HK lights are one way to do that. Small spotlights are mounted on adjustable rings attached to the trees and can have both up and down lights. Notice how the path in this photo is lit solely from the ambient light from the spotlights and the surrounding trees and shrubs. This type of concept is not practical for most public spaces, but could work well for residential or private spaces. Niki showed this photo a little bit earlier. This is from the Great Park in Irvine. Notice all the layers of light used in this lighting concept. We have some in-grade mounted lights. We have uplights on the palm tree and the other tree in the center. Plus there are some pole mounted lights. And lastly, there are lights on the adjacent building in the background. Notice how all the lights appear to be balanced. No one fixture is dominating your attention. Stairways are an application that you might get called upon to light. Obviously, you could use overhead pole lights or catenary mounted lights, but typically some sort of step light or wall mounted light is used on a sidewall or in the face of the steps themselves. This photo shows a typical Bega step light. Here, similar lights were used to illuminate a walkway and then continue up the curved stairway. One of the newer ways to illuminate stairways is with lighting that is concealed in the underside of the code-required handrail. This is an example from Intense Lighting and is called V-Rail. Notice how even the illumination level is on all the steps. If you are concerned about safety at a public stairway, this method will allow even people with poor vision to see where they are going. You can also use these sorts of products on bridges and pathways where they need a guardrail. You can specify either symmetrical or asymmetrical light distribution. Let's see. So that concludes our presentation. We have about 10 minutes left, and I think we're going to open it up to questions.
Thank you both. That was very, very informative, really fascinating. I loved all the ideas that you guys showed and shared with the participants today. I'd like to introduce Rex. He's also on the Emerging Professionals Committee with me, and he's going to moderate the questions today.
Hi, everyone. Looks like no one has any questions so far, but I guess I can start it off first with, I was curious to see if putting effective pedestrian lighting into public spaces and things like that, do you see that it increases the use of that space at night? Or it just kind of depends on more of the programming of what's available there for a nighttime use?
Absolutely. Yeah, lighting a space appropriately will encourage people to use the space, you know, at night if it's done in a way that promotes safety. So like some of the images that we looked at, where you have a better sense of being able to see beyond maybe trees or buildings and things like that, to know who you're approaching and what's in the space. Definitely that lighting comes into play when making those spaces more accessible at night.
Great. Looks like we have some questions coming in. The first one we have is from Lacey Withers. She asks, do you feel bollard lighting is an acceptable lighting for a park path when used alone?
So there definitely is a huge benefit to using layers of light. If you're just using bollards, there may be an area that is neglected or a little bit too dark to promote a sense of safety. There's an excellent presentation by Ely, actually, as an organization that focuses on landscape lighting, and they talk about the different layers and how that will impact the overall feel and sense of security within a space. And just having the bollards, if there's this depth of area that is too dark and maybe there's no facade lighting on a building or something to kind of balance out the light levels, then you can almost get the sense that someone could be just around the corner or behind a park bench or that sort of thing. So it depends on the application, but most of the time you want to have different layers.
Great, thank you for that question, Lacey. And the next question we have is from Mark Escobar. He asks, when it comes to lighting standards, can these vary depending on the city or ordinances and zoning? Or do they typically override the aforementioned standards that you mentioned in the presentation from like CSA and UL or other?
Yeah. So definitely there are standards that are set forth by, for example, the Illuminating Engineering Society and California Title 24, but from city to city, from different regions, you will have maybe an extra layer, maybe a more stringent requirement. For example, when we talked about foot candles, there could be different requirements in different cities for how many foot candles or a foot candle average that they require for certain applications. So that's definitely something, another layer of standards and requirements that you want to pay attention to is what the city requires.
Well, and sometimes too, certain inspectors are more stringent or more by the book, whatever you want to call it, you know, from certain jurisdictions. So just like with the building department, you know, it can vary a little bit, definitely.
Right, and we have another question from Yulia. She's asking, how is the CRI measured? And if there are any tools to measure that, or if that's just something that's provided in the specification by a manufacturer?
So that is provided in the specification, but there are also tools that help measure that. I think there are even phone apps that you can download and get a sense of. If I'm not mistaken, I know you can measure the actual light output and lumens, and maybe the lumens per, not lumens per watt, but the actual light output with apps. And so there are those things within your phone you could use, but then there are also devices that you can use to measure the characteristics of light. And there's like a wide range of different tools from various, from low end to high end to do that. If
Yeah,
you're talking about it in person.
I'm sorry, Nikki. Go ahead.
Oh, well, I was just gonna say, if you're talking about an in-person, if you're looking at a sample or something on a site, yeah, there are tools to measure.
Oh, and I was going to say, with that instance that I showed where the two fixtures had 3000 K lights, but they were different colors, we looked into, how could we actually measure the color temperature? And there are devices that are available, but they're very expensive. So I'm sure the color temperature or the CRI ones are even more expensive to try and figure that out.
Great. And the next question we have is from Nick. He notices that LED lights seem to be the best use for most applications for, how long they last and how efficient they are. So he was wondering if there are any other types of lights that would be preferable to use than LEDs for any specific uses, such as maybe, lighting a baseball field or stadium or other things like that.
So I think we've kind of arrived in a place where LED is more prominent or preferred, like in a sports type of application. But if you look at applications like landscape lighting with the smaller spots and floods and things, there is still a use of like Sora lamps, for example, and maybe some more traditional technology or lamps that are used. But for the most part, almost everyone's completely moved into using LED. We've gotten close enough to not perfectly replicating the traditional sources, but yeah, for the most part, LED is going to be a great choice. And whether, I think sometimes the choice between whether there's an integrated LED when you get into the spots and the smaller floodlights versus a Sora lamp that you would place in the fixture, that's usually more of a consideration, just because sometimes with those smaller scale fixtures, you want to have that adjustability. You can change out lenses and things after they've been installed. So hopefully that answered the question. I don't know if Mary Kay has anything to add.
Yeah, I would say I had my own personal experience. I have some older MR16 type outdoor lightings in my yard, and I just the other day had to go to Home Depot and replace some bulbs, and you cannot buy MR16 lamps anymore. Everything is LED. And when Nikki and I go to lighting shows, everything is LED. I mean, there's nothing else, because it just is so efficient now. And, they've gotten the color to where it's high CRIs and that kind of thing. And all of the other light sources like metal halide and sodium vapor and all of those just have so many disadvantages or problems that I just don't think you can even find non-LED fixtures anywhere.
Okay, cool. So it looks like we have room for one more question, and it's from Steve Lang. And he asks, have you worked with any projects that use color lighting that is programmable, and to be able to be changed for seasonal uses.
Yes. Yeah, we've had several projects where we've done full color changing light or building facade type of lighting that's going to change color from seasons, or even has the ability to, for example, we have a manufacturer that we work with that has what they call media wallpaper. And that's kind of an interactive wallpaper type of fixture that you can wrap around an architectural feature. And that's actually for interior or exterior use. And it gives you this ability to program scenes and interact with the light in a space. So full color, all types of effects and controls. And yeah, absolutely. We've done projects like that and have manufacturers that can provide those types of products.
Thank you, Niki. Thank you, Mary Kay. This was a great presentation. Super great slides showing all of your wonderful lighting that you have at DSA, and also giving us some great information and great tools for our lighting projects. Please, everybody, take a screen capture of Mary Kay and Niki's information on the screen if you don't have it already. And I want to thank you so much, and thank you again for being such generous sponsors of ASLA SoCal. We really appreciate your generosity. Thank you, everybody, for attending. More webinars coming soon. We hope to see some advertisements on our schedules in the coming weeks. So stay tuned for more lunchtime webinars. Have a great rest of your day, everybody. And thanks again, Niki and Mary Kay, and thank you, Rex and Sarah, for putting together this wonderful webinar.